Alright, in this video I will teach you how to graph square root functions like this one and cube root functions like this one. And we will do it without using a graphing calculator or even a TI-30XS multiview. That'd be almost like cheating. Alright, so here's the thing. Let's zoom in on number one. When you graph a square root function, I recommend that you start with the parent function, which is just the square root of x. So forget about all this other stuff and just focus on the square root of x. That way you can always start with the same x values. You can't take the square root of a negative number. You can take the square root of 0, which is just 0. So we don't need a calculator if we choose carefully. How about the number 1? We can take the square root of 1, and that's just 1. After that, another easy value would be 4. The square root of 4 is 2. After that, the next easy value is 9. All right, these are all perfect squares, so 9, because the square root of 9 is 3. And finally, I'll add one more, though this may not fit. The square root of 16 is 4. So we can always start off with these values if we are talking about a square root function. Now, when you have multipliers, either outside or inside, and sometimes I'll talk about a values and b values, and if I do, it's because I'm referring back to this model for a square root function that would be like this: b times x minus h and then plus k. So sometimes I'll talk about if there's an a value or if there's a b value. So when there's an a value, all right, like this negative 2, then we're going to create a new y column. And if there's a b, we're going to create a new x column. So we're going to have to create a new y column because of the a. All right, so I will just do that right here. Okay, and my new y column is just going to be a times y. But in this case, a is negative 2, so I will go ahead and say negative 2 times y. In fact, I probably should just write that here. And maybe up top here, I'll put ay as a general thing. Okay, so I'm going to do negative 2 times all the y values. So negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. And negative 2 times 4 is negative 8. Okay, so once you have your new y column, you can throw out your old y column. All right, we're going to use this for our y values now. Okay, so that takes care of this. All right, now we've done that. Now, there's also a b value. Our b value is negative 1. So whenever there's a b value, you're going to make a new x column. All right, you're not going to be able to see it here, but whenever we make the new x column, what we do is we do the reciprocal of the b value times all the x's. All right, like 1 over b is a way of saying the reciprocal of b. But the reciprocal, and it just in case, when I say this word reciprocal, like if I had 2 over 3, the reciprocal is 3 over 2. So it's like you're turning it upside down. But the reciprocal of negative 1 is still negative 1. So I am going to wind up multiplying by negative 1, but just in the back of your mind, please understand that we are doing the reciprocal. So if this had been -3, then I would do -1/3 now. Anyway, so I'm going to multiply -1 times all of these values. So that's going to be 0 and -1 and -4 and -9 and -16. Okay, so those are my new x values. So once you have new x values, you can cross out your old ones. So these are the x values and y values that I'm going to plot on this graph. So now we have taken care of this, the b value. Okay, so let's plot it and see what we have so far. So 0, 0 is right here. -1, -2. -1, -2 is right here. -4, -4. -9, -6. All right, and of course we can't fit the -16 because it's a bit too far. So this is what we have. Now I'm not going to connect these dots, all right? I'm just going to leave it as a skeleton because what we have not yet done is we haven't done the +1 and the +3. Now you need to understand that the +1, anything being added or subtracted in here is a horizontal shift, but it will be in the opposite direction of what you would normally think. So this represents a shift left 1. Now anything out here on being added or subtracted on the end is an up or down shift. So this represents a shift of up 3. So we've got left 1 and up 3. So that's what I'm going to do. I'm going to take each of these points and move them left 1 and up 3. And that will be my final answer. Okay, so left 1 and up 3. Left 1, up 3. Left 1, up 3. Left 1, up 3. Okay, so this is my final answer. So I will go ahead and connect these points. Now understand that this function starts at this starting point, and it only goes in one direction. In this case, this way. Okay, so don't draw an arrow through this and think it's going the other way as well. It is not. Now, my lines are disappearing. If this disappears again, I'm going to have to wrestle with it off camera. Okay, so that is the end of our graph. So let's go ahead and answer some questions about it. Okay, the starting point. All right, well, this is the starting point right here. That was left 1 and up 3, so that's -1, 3 is our starting point. Okay, increasing or decreasing? Well, when you talk about increasing or decreasing, you look at the graph from left to right. And from left to right, this is always increasing. Okay, so increasing. Now the domain. So domain is x value, so left to right. So to the left it goes forever, -infinity. To the right it goes to -1. So looking at the x-axis, this goes from -infinity to -1. That's the domain. So -infinity to -1. This will get a bracket on the -1 because -1 is a point on the graph, so it is included. Now how about the range? Range is y values, and it should be written from least to greatest. That means from bottom to top. So what's the lowest y value? -infinity. It goes down forever. Now what's the highest y value? Highest y value is here at 3. So -infinity to 3. all right, negative infinity to 3. Again, it needs a bracket. Now, does this graph have an absolute max or an absolute min? All right, does this graph have a high point or a low point? This graph has a high point right here. There's no point higher than this. So this is the absolute max, and it is at 3. Okay, when we talk about max and min, we are really just talking about the y value. So this has an absolute max at 3. Okay, just the y value. There is no absolute min. It goes down forever. All right, anything else? Okay, the end behavior. All right, when we talk about end behavior, we talk about what's happening on the left side of the graph, and then we talk about what's happening on the right hand side of the graph. Okay, so first let's look on the left hand side. Okay, so this is the left end behavior right here. So on this left end, all right, what are the x values doing and what are the y values doing? Okay, so the x values, all right, so looking from left to right, it's going to negative infinity. Okay, because it's going to the left forever. Now, what are the y values doing? Y values are up and down. Is this up or down? Okay, it's going down, so that's going to be another negative infinity. So that means we will say on the left, as x approaches negative infinity, okay, all right, that's what the x values were doing, then the y values are also approaching negative infinity. So negative infinity, negative infinity. The x values are going to negative infinity and the y values are also. Now let's look at the right hand side. The right hand side is over here. All right, so what's the x value of this end? Well, the x value is negative 1. Okay, so the x value is negative 1. What's the y value? The y value is 3. Okay, so remember that, negative 1 and 3. All right, so as the x values approach negative 1, the y values approach 3. So that's the end behavior. Okay, as far as this video goes, let's do one more problem. Okay, let's do number 2. Now, notice this is a cube root function, not a square root. So cube roots, we will still deal with 0, all right, because I can take the cube root of 0. Now, just if you're not really familiar with cube root functions, just understand this. Think about the function x to the third power. Okay, if I have 0 to the third power, that's going to be 0. If I have 1 to the third power, that's 1. If I have 2 to the third power, that's 8, because 2 times 2 times 2 is 8. If I have 3 to the third power, that's 27, because 3 times 3 times 3 times 3 is 27. On the other hand, if I have negative 1 to the third power, that's going to be negative 1. Negative 2 to the third power is going to be negative 8, and negative 3 to the third power would be negative 27. Okay, so keeping that in mind, when we do cube roots, we're going the opposite direction. So the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. Okay, so when we do the y values, let's start with the parent function, that's just the cube root of x. So the cube root of 0, as we said, is 0. The cube root of 1 is 1, and the cube root of 2 is, sorry, not the cube root of 2. I meant to say the cube root of 8 is 2. Okay, so I'm using 0, 1, and 8. Now, I left this space up here because unlike square roots, where we could not take the square root of, say, -2 without involving imaginary numbers, but we can take the cube root of negative numbers. So the cube root of -1 is -1. The cube root of -8 is just -2. Okay, so anytime we are dealing with a cube root function, we're going to start off with these values. Now, remember, if there's an a value, all right, meaning a number out here in the front, I'm going to need a new y column. But if there is a b value, I'm going to need a new x column. And so I don't need a new y column for this problem because there's no a value. I will need a new x column because there's a b value, -1/2. So in retrospect, I should have moved this chart over more to the right. So I think I'll pause and move it over. All right, so we're going to need a new x column. So I'm just going to stretch this off to the left to make my new x column. All right, you make the new x column by multiplying by the reciprocal of this b value. So if I've got -1/2, the reciprocal is going to be 2/1, okay, which is just -2. So that's what I'm going to multiply all my x's by. So I'm going to do -2 times all my x's. Again, I'm just doing the reciprocal of this to make my new x column. Okay, so -2 times -8 is +16. -2 times -1 is +2. -2 times 0 is 0. And then I've got -2 and -16. Now, once you make a new x column, you can throw out the old one. So I'm going to use these x's and these y's. Now, really, only these middle 3 values are going to fit. So it kind of helps to know what the graph in general looks like. But for now, let's graph these 3 points. Okay, so I've got 2, -1, so that's right here. I've got 0, 0. I've got -2, 1. Okay. Now, in general, cubic functions look sort of like, okay, either like this, or they look like, if they start high, then they look like this. Okay, this is what cube root functions look like, sort of like waves or S's. Okay, so if you keep that in mind, so we're going to draw one of those waves through this point. Okay, so and also it helps to keep in mind, well, you know, I'm not going to actually connect the dots yet. I'm getting ahead of myself. We haven't done the -2 and the 1 yet. So slow down, slow down. So the -2, that's going to be a shift to the right 2. And the +1 is going to be a shift up 1. So right 2 and up 1. Okay, so the real graph will be what I get if I take these 3 points and I go right 2 up 1. So right 2 up 1, right 2 up 1, right 2 up 1. So I'm going to draw that wave through these 3 points for my final answer. Okay. Okay, so that's what that half would kind of look like, and that's what this half would kind of look like. So something basically like this. And of course it disappears, so that's great. I don't know why it hates me. Don't disappear. Okay, so your graph should look something like that. Okay. So now I guess it's time to answer these little questions and then we'll be done. Starting point does not apply to cube root functions. This has no beginning and no end, so I'm just going to write none. Is it increasing or decreasing? Well, you have to look at it from left to right. And from left to right, it's like, whee! We're falling. It's like sledding down a hill. So that's decreasing. All right, it has to be left to right. The domain and range will always be the same for cube root functions. They go left forever and right forever. So the domain is negative infinity to positive infinity. And they also go down forever and up forever. So the range is also negative infinity to positive infinity. So that's true for all cube root functions. Now, absolute max or absolute min, there won't be any because of what we just said about the domain and range. It has no high point and no low point. It keeps going. Okay, now the end behavior. So remember, the end behavior is all about what happens on the left. Oh, I don't know what that letter was getting ready to be. But it's all about, this part of the end behavior is all about what's happening on the left end of the graph. And this part of end behavior is all about what's happening on the right end of the graph. And so we have x's and y's, really. So on the left end of the graph, what are the x's doing and what are the y's doing? Okay, so over here on the left, the x's, all right, remember x's are left and right. So on this end, the x's are going to the left forever. So that's negative infinity. Okay, the y values, okay, y values are up and down. So which is it on this end? It's going up, so that's positive infinity. So it's going left and up. That's negative infinity and positive infinity. So that's this part of the end behavior, negative infinity and positive infinity. Okay. Now let's look at the right end of the graph. Okay, here's the right end. Okay, it's an arrow. So first, let's talk about what the x values are doing. Well, the x values are going to the right, okay, because the choices are left and right. It's going to the right, so that's positive infinity. Now let's talk about the y values are doing. For y values go up and down. So is this going up or down? It's going down, so that means the y values are going towards negative infinity. So as the x values approach positive infinity, the y values approach negative infinity. So that's the right-hand side. Positive infinity, negative infinity. All right, and that is it. That is how you graph a cube root function and a square root function.